colleagues, I welcome you. As planned, we are currently testing the outer shell of our first airship, NOVA 01. We are testing its strength characteristics and checking its airtightness. And already now, you can observe its external appearance, which in the future we will see in the sky. Shamil, tell us what's happening here today. What interesting things can we share with our viewers?
Today we are testing the shell. This shell was made with multiple solutions, which will help us operate it in various conditions. For example, we have the attachment fins here. We can notice that this grommet is used only for the pipe. And we have incorporated additional parameters so that if we lack certain rigidity and the pipe presses into the shell, we place a reinforced pad here, increasing the specific area, and it won't press into the particular shell as much. For the tail fins, we will have servos, and we have laid out these cable channels for their connection.
Shamil, can you tell me what this place is intended for?
On the shell, we will have 4 fins. This place is needed to tie them together with straps and give them enhanced rigidity, such as. Also, a place was made on the shell for a gas valve. In our conditions, it is not used. It serves to regulate the gas volume and, if necessary, to release some helium to lower the flight. Here we have a thruster, and this element is intended for its more secure fixation. The thruster is specifically utilized because at low speeds, the fins cannot handle it effectively, and we use it to turn the airship.
Shamil, our tail section is indeed quite unusual. As I understand it, special stiffening ribs will be inserted into these slots, on which the thruster will be mounted.
These ribs allow for a more rigid fixation. We need the thruster for turning at low speeds because the fins can no longer handle it. The shell itself consists of 12 petals. One petal is a segment like this, which runs along the entire length of the shell. The lower petal has the most elements. Here we can see the pads for the valves and fans. The valves and fans consist of 2 parts. To simply put them on, you need to reach through this hatch and secure them in this unit.
We are not installing them right now because we are testing the shell itself.
Yes, we are doing fittings and tests of the shell. Here we have the elements for attaching the gondola. In this area, we have a platform for mounting magnetic sensors and GPS sensors. They will be covered with fabric on top, which prevents moisture from getting in. In the front part, there is a similar sleeve. During tests, we pump air in here to check the tension of the shell, but during operation, we will fill helium through this opening. The valve also consists of 2 parts, meaning we insert a hand through the inner part and screw the 2 parts together in this area, as well as when the flight is terminated.
Shamil, what happens to these sleeves in the finished model? Do they stick out like that, or are they trimmed somehow?
No, when all the elements are secured, the sleeve goes inside and is laced up.
We are now near the nose reinforcement of the airship NOVA 01. It has quite an unusual design. Shamil, what is the reason for this?
The nose section is the most heavily loaded, so we use 12 power beams here. Here is one of them. It will be attached in this form. And we will also have reinforcement here, which will allow us to suspend it on the mooring mast.
Alexander, I was told that you could answer my question about why these sleeves are here.
Well, these aren't sleeves. This is our manometric tube. This is our pressure receiver, and this is our shell. Our shell consists of 2 parts, the gas volume and the ballonets. We were just conducting tests for strength and tightness. Strength refers to our durability. We applied high pressure, and our shell did not burst. As for tightness, we applied working pressure and checked to ensure it didn't drop over time. This means the gas won't escape. We measured the pressure. This pressure receiver went through this manometric tube to the sensor, and from the sensor, it went to the screen. This is from the gas volume, and there's a similar setup for the ballonets. So, we are essentially working with 2 pressures. That's basically it.
Sergey, I just spoke with Alexander, and he was telling us about the internal pressure measurement sensors in the airship. As I understand it, there are two here. One measures the gas pressure inside the envelope, and the other measures the air pressure in the ballonets. Could you tell us more about the ballonet function and its role in the airship?
The ballonet is right here. It's this large part of the envelope.
1/3 of the airship?
Somewhat, yes, it varies. In this case, almost its entire volume is inside, so here we only see the seam. It serves to maintain the aerodynamic properties of the entire envelope during flight. When the airship descends during flight, the atmospheric pressure increases, and consequently, the volume of gas in the envelope decreases and compresses. We need to increase the volume of the envelope, and this is done by filling the ballonet. Here on the ballonet, we have fans and valves, such as the fans are utilized to effectively fill the volume of the ballonet, such as during the descent of the airship, and, on the other hand, the valves are utilized to release pressure when the airship ascends to higher altitudes. Because when we move upwards, such as when we ascend, the pressure decreases, and when we move downwards, for instance, when we descend, the atmospheric pressure correspondingly increases, in particular.
Sergey, I see that neither the fans nor the valves are installed yet. When are they planned to be installed?
We will install them before the start of the envelope's operation, cutting them into the openings that are provided for these purposes. At this stage, we conducted tests for tension and strength. Accordingly, they were simply not needed and would have been in the way.
We have already successfully installed the nose reinforcement and also the mooring unit, which our airship will be securely moored to currently. We have also already successfully fitted the tail assembly and carefully installed the thruster in the tail section of our airship. In addition, we also finished assembling the airship's gondola, fitted it, secured it, checked that everything was satisfactory, disassembled it, and tomorrow we will move on to testing the software. Today, I would like to outline some of the tactical and technical characteristics of our airship NOVA 01. It has a total volume of approximately 130 cubic meters, an overall length of about 17 meters, and a maximum diameter at its widest part of 3.7 meters. This parameter is also called the midsection. I learned that today. I would also like to note that the speed of this device is expected to be around 60 to 70 kilometers per hour. The lifting mass of this device, or rather, the target payload that this device will be able to lift, is about 20 kilograms, but this is not yet certain. We will conduct the final weighing measurements later, and accordingly, we will also find out the exact figure for the target payload later, but we expect it to be approximately 20 kilograms. To completely fill this shell with helium, approximately 110 cubic meters of helium will be needed. The maximum altitude that this device will be able to reach is about 1.5 kilometers, but naturally, it will not be flying at such altitudes. Its operating altitude will be approximately around 500 meters, which is sufficient for the airship to effectively perform the tasks it will be assigned. I also want to remind you that this device is a scaled-down version of our future device, the NOVA 2, on which we plan to thoroughly test all the various control systems, mooring, landing, and software, so an altitude of 500 meters will be more than sufficient in order to ensure everything functions correctly. So, in conclusion, I want to note that we have conducted all possible ground tests here. We have carefully checked the shell, and very soon we will head to the very familiar Kearshack, where we will thoroughly conduct the final tests, final assembly, and meticulously perform the first launch of the airship. Let's keep up with the news together, subscribe, stay active, and we'll see you in the next video.